All right, we're finally recording. Okay, so this problem here, very, very important. And this problem here has calculus implications as well. So if you go on to take calculus, you'll see this kind of thing again. You will definitely see this on the test on Thursday and even on the next test, okay? So this says f of x plus h minus f of x all divided by h. We need to set this up, then simplify it, okay? So how are we going to set it up? Well, the first term in the numerator is f of x plus h. And so if we retreat back to where we were doing yesterday, we saw that f of x is 3x squared plus 2x minus 4. So let me come down here and rewrite it. F of x is equal to 3x squared plus 2x minus 4. Now, some people were coming in this morning and they were having a hard time plugging into the function. A lot of people had this, and this is the most common mistake. If I want you to find f of x plus h, some students do this, 3x squared plus 2x minus 4 plus h. Is that right? No, because what this is doing is you're just taking f of x and adding h onto the end. It's not equal to that. This is actually equal to f of x, close parentheses, plus h. And that's not what we want. We want to actually plug in for both x's the quantity x plus h. And so like I mentioned in class, you want to write this as f of blob, parentheses, equals 3 blob squared plus 2 blob minus 4. It seems a little bit silly to do that because we're going backwards from algebra. We're using open parentheses instead of an x to represent a variable. But until you're comfortable plugging in quantities for x that are more than one term, do this, okay? It makes perfect sense. So that now whatever you see right here is going to be the same thing you drop in right there and right there, okay? So let's do that. Working straight down now from this expression, I need to evaluate f of x plus h. So what is that going to be? Well, let's see. It's going to be 3 blob squared plus 2 blob minus 4. I'm going to get this out of the way now, put it up here so that I have room. So that takes care of the numerator, and I'll highlight it. But notice I haven't even plugged anything in yet. What does it say I'm going to plug in for x? I'm going to drop in an x plus h, okay, into both places. So I get x plus h and x plus h. That's the first term in the numerator of this expression. Now I'm going to write the minus sign, minus. And I'll use, let's use green for the next one. Now, whenever you put a minus sign, you have to be especially careful about what follows, especially if it's more than one term, because you're going to have to distribute. So what I would recommend here, because there is a minus sign, is putting a bracket, not even a parenthesis. A bracket's a little bit more important, okay? And now it says f of x. So I'm just going to go ahead and write it out again, 3 blob squared plus 2 blob minus 4. And now, what am I going to plug into the parentheses? An x, right? So really, all we're doing is rewriting the function. But again, you can still have the same mindset. I'm going to replace x with x, and I get that right there. Now notice that the parentheses here, or the brackets, are super important, correct? Because what is eventually going to need to happen with this negative? I'm going to have to distribute it. And if you don't have the parentheses there, you're not going to change the signs of these last two terms. And it's going to be wrong, wrong. Okay? So, very important. Parentheses or brackets are your best friends in this class. It's better to have them and not need them than to need them and not have them. Okay, and then all of that is over Herculean H. H is holding everything up. And it's frozen. Sweet. Love that. There it is. Okay, so we've now set it up. You're going to get a check for setting it up each term on the test. I'll give you a check for this pink part, and then if you have minus parentheses in this, you'll get the second check. If you don't have the parentheses, or you haven't distributed the negative, which is another option, I would tell you probably to be careful about doing that, you're not going to get this check, and you're probably not going to get anything else after that because it's not going to be correct. All right, so now that we've set it up correctly, and by the way, you could even put brackets around here if you want. Because what that would show then, it would kind of show where they're coming from, right? you have this piece in brackets minus this piece in brackets. So they're there to organize as well, not just to keep you from making careless mistakes. But now what we have to do is we have to expand out the entire numerator. Okay? So to do that, we do it carefully. The 3 goes along for the ride because we have to expand the binomial squared first. Remember how we expand a binomial square, the quick, fast way? Good. Square, multiply, double, square. Square the first, you get x squared. Multiply, you get xh. Double it, you get 2xh. And then you square the last, you get h squared. And I still have the 3 out there because I wasn't going to square, multiply, double, square, and distribute a 3 at the same time unless you can. Okay? There's a way to do that, but in the beginning, don't. And now I distribute the 2, so you get 2x plus 2h minus 4. Now the important part, right? I got to distribute that negative. So it's negative 3x squared minus 2x and plus 4 all over h. Remember, as you work straight down, you have to bring everything along. These are expressions, and every expression below and above another one have to be equivalent. So now the last thing I'm going to do here is distribute the 3, and I get 3x squared plus 6xh plus 3h squared. And then I'll just go ahead here and just rewrite everything else. And I'll just go ahead and combine like terms on the next line. So it is a little bit of rewriting. Actually, a lot of rewriting. But rewriting should be the easy part, right? You're not really thinking, you're just carefully transcribing from one line to the next. Now here's the cool part. With everything set up and expanded correctly, good things should happen in the numerator. Great things actually should happen in the numerator. Everything that does not have an h in the term should in fact cancel. So here's your chance to catch a possible mistake of maybe not distributing up there. Make sure that it actually does cancel and don't just cross things out. So I've got a positive 3x squared and a negative 3x squared, right? Those are opposites. They cancel to give you a 0 pair. Here's a 2x without an h. That plus 2x cancels with this minus 2x. And notice that if you did not distribute the negative, instead of 2x minus 2x and have them cancel, you would have 2x plus 2x, and you'd have 4x's now. That's not good. Here's a negative 4, and that cancels with this positive 4. And again, if you didn't distribute, you would have minus 4, you'd have minus 8. So that's it. That's all that cancels. But notice everything that's left, these 3 terms, they all have a what in them? An h. So if you did end up with plus 4x minus 8, those 2 terms would not have an h in them. And you'd be like, uh-oh, everything's supposed to cancel if it doesn't have an h. Then you can come back up here and like, I didn't distribute. And then you go back up there and you fix it, okay? So now the next step, if everything in the top has an h, it's a common factor in all 3 terms. So now you're just going to factor the h out, and then you're left with 6x plus 3h plus 2 all divided by h. And now the best part of all, right? What happens with your h factors in the top and bottom? They don't cancel. They divide out. There's a huge difference, right? Things cancel to give you 0. Things divide out to give you 1. They are gone, but cancellation means getting a 0. And we get a 1 here. And so your final answer, believe it or not, is 6x plus 3h plus 2. That's your final answer. That is my favorite problem. Okay? Think y'all can handle that? There's one on the worksheet that has f of x plus p minus f of x minus p all over 2p. It's pretty much the exact same thing. Let's go ahead and give y'all one of these to practice, okay? I'll give you another one. Extra practice. Write this down. Let's use h of x instead of f of x, right? It's kind of boring using f of x all the time. Let's call h of x 3x squared plus 5x minus, what's a good number? Help me out, anyone? 3? Another 3? Okay. Let's do that. And then let's go ahead and set up and simplify the following. I want you to set up h of x plus k minus h of x all over k. So I changed some of the variables, right? Instead of f of x, we're using h of x. And instead of using h, or like p in the worksheet, I just chose k. K is some constant. But this should set up and work out the exact same way. So go ahead and do that, set it up, evaluate it, and get down to your final answer. And I'll be walking around the room, checking to see your progress. And if you're watching the video at home, you don't even need to hit pause. You just keep it going and you practice on your own. The setup is really the most important part, because if that's not correct, you're not going to get the right answer. And I'm not going to be too forgiving on partial credit if you don't set it up correctly. And if you need to kind of refer back to the one we just did, that's fine. That's what they're there for. You have an example of something that successfully works. It's very similar. You build on previous successes. Yeah, okay. Not bad, but there's one critical thing that I was emphasizing in the last problem that you did not do. All right, so those two signs would not have changed. So that's okay. You don't need them here because there's nothing to distribute. But when it follows a minus, you got to be extra careful. Now that's the same. Good. And now you could drop in your respective variables. Parentheses are your best friends in a math class. Better to have them and not need them than to need them and not have them. No, because you haven't. Well, you still have the H's. They should be gone when you go to here. But remember, what are you doing? You're supposed to be plugging x plus k in for x, right? Now you plug this into there, not the other way around. Remember, you haven't done what I told you to do yet, and you're not getting it right. So that would be 3 parentheses squared plus 5 parentheses minus 3. And then what are you going to do in the first term in the top? In each of those parentheses that I just said, you're going to drop in an x plus h. Okay? If you're not having success setting it up and you're not doing this right here that I highlighted, it's time to do this first, okay? I can't emphasize it enough. If you can't set it up right, it's not going to work. You did, but that's just the first term. That's just h of x plus k. So now you're going to have to go minus the other one. Right. If you're working on it, that's great. If you haven't got it set up yet, here I'm just going to show you what to do. And I like what Justin did back there. H of blob equals 3, blob squared plus 5, blob minus 3. Notice you have the function twice in the numerator. You're doing the function evaluated somewhere minus the function evaluated somewhere. So here's what I would recommend doing. Just go ahead and put a bracket and then copy this down twice. Put 3 blob squared plus 5 blob minus 3. That's the first one. Minus bracket, do it again. 3 blob squared plus 5 blob minus 3. All over k. So you see what I've done? I've set myself up for success. I have basically just written this once, minus written it again. And I haven't bothered to plug in yet. It's just some form of the function minus some form of the function all over k. Now I will return as a second step, and the instructions say in the first term, I'm going to put what in the parentheses? X plus k. So I'm going to come over here and put x plus k, x plus k. Go me, right? And in the second term, what am I going to put in the parentheses? Plain old x. So x and x. That's the easiest way that I can explain it, okay? A function is a machine, and the x's are the input locations, okay? And we are inputting an x plus k into one and an x into the other. That's the setup. That's going to get a check for the first term, with or without the brackets. Again, the brackets are kind of nice because they do show locations. And then the second one is actually critical. If not a bracket, at least a parenthesis, because it's a minus sign, and those will have to change signs. Now, I'm going to go ahead and expand it in one fell swoop. I'm going to go ahead and expand the x plus k squared and distribute the 3 at the same time. And y'all can help me with that, right? So we're going to square, multiply, double square, and then I'm going to triple every coefficient. So x squared would be the first term, times 3 makes it 3x squared, right? To get the middle term, you multiply, which is xk. Double it, you get 2xk. So I have 2xk now times 3, which is 6xk. Plus square the last, you get k squared. Times the 3 gives you 3k squared. Now, if you can't do it in one step, don't, okay? I didn't do it like that up here. I kept it out, and then I distributed it as a separate line. You should work towards trying to do that, but if you can't do it, don't do it yet. Work up to it. Then plus 5x plus 5k, minus 3, minus 3x squared, minus 5x plus 3. Distribute that negative. And what that allows you to do is save a little bit of writing. There it is. And here is kind of your checkpoint. This line right here is your checkpoint. You'll know if you did it correctly, because at this point, whatever the variable is in the denominator, which is a k here, every term in the top that does not have a k should do what? Cancel. That's canceled. So make sure that it does. Positive 3x squared and negative 3x squared. Sweet. Positive 5x and negative 5x. This has to cancel. If you didn't distribute, you would end up with 10x instead of a 0. And same thing here, negative 3 and positive 3. That would end up being a negative 6 instead of a 0 if, in fact, you didn't distribute. So this is your checkpoint. And we're frozen on the Wi-Fi again. So that's gone. And then everything that's left, 6xk plus 3k squared plus 5k. This one here, and this one here, because the 3's are gone. They all have a what in it? They all have a k. So at that point, you could just factor out the k, and you're left with 6x plus 3k plus 5. And I'm hoping that it'll just kick into action here at some point. All divided by k. And then your k's divide out, and you should end up with 6x plus 3k plus 5. All right? So it's not showing up, but you should end up with 6x plus 3k plus 5. That was your final answer. Okay, it's really not working now. Hey, there's a Precal Matters. All right? Y'all get 6x plus 3k plus 5? 6x plus 3k plus 5. Okay, cool. So now you can go to the worksheet and practice the one that was x plus p minus f of x minus p. That one's going to be a little bit more fun because now in the second term, you're not just plugging in an x, you're plugging in an x minus p. You expand it all out. The same thing should happen. Everything without a p should cancel. And you'll factor out the p and then divide it out with the bottom. Okay? So we're going to stop right there for today. There's a couple minutes left. Tomorrow, when you come to class, the worksheet will be due. You have enough to finish the worksheet. I want you to practice on your own tonight by finishing the worksheet, and then come with questions tomorrow, okay? I will work extra examples all period long of the ones that you feel like you need help with the most. And if you run out of suggestions, I will just make up problems, okay? And that's what we'll do all day tomorrow. Guided practice, guided practice, guided practice. And then when you go home tomorrow night, remember that there's a link here that says links to old tests, right? You see that? You can click there, and you could find a test from last year and the year before that I actually gave in class over sections 1.1 to 1.3. And that should be your final preparation. When you think you've practiced and you have everything, sit down with one of those old tests, set the timer for 50 minutes, and see if you can finish it without looking anything up. Testing Thursday is going to be great because not only does it give us an extra day, tomorrow is the shortened class because of Rachel's Challenge Assembly tomorrow. Which, by the way, your Rachel's Challenge Assembly class is not the same advisory you had on the first 2 days of school. It's a completely different class. You can check out your class in Text Connect. If you go to Text Connect, it'll say advisory. It'll have your teacher in there. And that's going to be between second and third period. All right? And that's tomorrow and then every Wednesday after that. Cool. Any questions? All right, finish your homework tonight and then come with questions tomorrow.